Okay, let's begin the class. The first thing I want to discuss is about the solution to the homework. Okay, the homework is special because I haven't teach you about the second order ODE. Yeah, how to get the Euler solution for second order ODE. Okay, let us start from here, and then the first step is to express the highest order state in here. Yeah, what is the x double dot on the right side, and then after that, when we are using the Euler method, we know that this x double dot will be x dot k plus 1 minus x dot k divided by delta t. Okay. So instead of having the non-dot here, we have one of the dot. Okay. And this is equal to the top equation. Equal to the top equation. X double dot equal to this one. And then by the Euler method, this is equal to the x dot k plus 1 minus x dot k divided by the delta t. Okay, next, in this step, I multiply delta t to the right side. Okay, so I will get x dot k plus 1 will be equal to delta t multiplied by this whole thing, minus 1 over 3, 5xk, 5x dot k plus 7k, and then plus x dot k. Okay, so this term is coming from here. Up to this point, is this clear? And then I regroup the terms. Yeah, I'm still expressing x dot k plus 1, but then I regroup the term x dot k and then xk. So I have two terms. X dot k plus 1 will be equal to the current x dot k and also my current xk. So we cannot just write this in MATLAB and solve the equation. We cannot do that, okay? Because we have two unknowns. Two unknowns. What is the two unknowns? X dot and then the x. And we only have one equation. So we need one more equation. But how many ODE we have? How many equations already? One. From the beginning, we only have one ODE. Okay, but then we need two equations to expand the solution. Which is why we have to add one more equation. One more equation. Okay, what is that equation? Of course, it is in your homework. What equation is that? The one more equation we have to add. Nadia? We already have for x dot, right? Yeah, we need to have equation on x. So we need to explain what is xk plus 1. If we have that, then we can run the algorithm. Okay. Actually, we have one free equation. The free equation is the integral equation from x dot to x. Okay. What is the relationship between x dot and x? X is integral from x dot, or x dot is the derivative from x. Okay, that's one free equation that we will use. Okay, so I will express two new variables, which is x1 and x2. I will let x1 equal to x, our original x, yeah, it's x1, and then my x2 will be the x dot. After that, I will express the derivative of each of this. So x1 dot will be x dot, right? And x dot is x2. So x1 dot is x2. So this is the additional equation that we bring into the ODE. What about x2 dot? Yeah, x2 dot, if I bring x2 dot in here, so the dot in here will be added, right? X2 dot will be x double dot. So we have it here. and x double dot is simply the one that we have on the top. Okay, just bring that here. After we bring it here, we replace the x dot and x with x2 and x1. So after that, yeah, this is the last part, yeah, the last part of the previous slide. So I bring it here. What to do from here? After we have that, then we express in simpler terms. So this part is just I remove the x dot and x double dot so that it becomes shorter. But this one is the same with that. After that, we can apply the Euler method. Euler method is applied to each of them. Okay, each of them you apply Euler. Each of them you apply Euler. So this is the format for the Euler method. And then for x1 dot, I'm using this, and for x2 dot, I'm using this. Okay. So for each of x1 dot and x2 dot, I apply the Euler method. After that, I can obtain the expression for my x1 k plus 1. And then this is x2 k plus 1. Yeah. So this is basically telling us the future x. And this is telling us the future x dot. Okay. And so I just bring this to here so that you can clearly see it. Okay. Now MATLAB codes. MATLAB codes is just repeating what we did last week. Okay. So like this, we have two initial states. I think you also have two initial states, yeah, but maybe with different notation. And then the loop for is in here. Okay, nothing changes from the last week. And then we just plot. One thing that I haven't talked is about expressing the time vector. Okay, last week we only plot the vector x, yeah, without having the time vector. But now, if you want to get the time vector, then it is just from 0, and then the increment is the dt. dt will be the increment. Okay, dt that you express here, the time step, that will be the time increment on your vector time. And the n time will be this one, the n of k multiplied by your dt. And then this will be the result. If you choose 2 and 3 to be the initial state. Yeah. If you choose different initial state, of course the result will be different. Any questions so far? Clear, yeah? Anyone did the homework like this? Expressing x1 and x2? How do you get the solution? From where you get the idea to get the solution?
Double dot equal, and then like get 5/3.
Yeah.
For the loop, yeah. And then it must be 0.001. Then initial state is the same.
Oh, okay. I will check your homework then. Okay. The next topic is expressing the Euler method in matrix form. Okay. So you see we have two elements in here, the x1 and x2. So I can write down this equation as a vector and matrix equation. Okay. This vector 2 by 1, and this will be the matrix. I call it matrix A. Okay. And then this x1 and x2 as a vector, I call it z. Yeah. I call it z. So z is a 2 by 1 vector. So in MATLAB, I just have one line in here, yeah, for the dynamics of the system. I only have one line. Compared to the previous case, we have two lines, yeah. But then in here, I express what is my matrix A. My matrix A is there. I can put it on the top because it is a constant matrix. Throughout the simulation, it is constant. Okay. So this is the loop 4. The loop 4 is computing the z instead of x1 and x2 separately. This one compute all in one go as a z. Okay, and then the initial state I make it the same with the previous case. 2 and 3. 2 is x1, 3 is x2. Okay, so after that, if I want to plot x1, then I just pick x1 to be the first element of the z. Yeah, x1 will be the first element of z. This is how we do it. And then plot it again, get the same curve. Okay. Any questions so far? Okay. So in this case, we express the matrix form from the scalar form of Euler. Yeah. This is the scalar form of Euler, and then we bring it into matrix form. However, we can also do it from the original ODE. Okay, from the original ODE, we make it into a matrix. Okay, this one. So from here, we make a matrix equation. Yeah, and on the z, I will apply our Euler method. So this is called the state space equation. Euler method on the z, yeah, you see basically the same. Zk plus 1, this is zk, and then delta t. What is azk? That is this one, yeah, the z dot. So finally, I get the same matrix as we have previously. So you can start from here, or you can also start from individual Euler terms, resulting in the same solution. Okay. Any question? No. Okay. David, is this okay? Madeline? Okay. No, not okay. Okay. So today we will simulate a car accelerating, yeah, using the Euler method. So I wanted to do it. So this will be the governing equation. Non-linear here because we have x dot square. Okay. Can you plot time versus x? X is the displacement of the car. We will assume Ft, the traction, to be a constant, 1000 Newton. Yeah. Now can you do it using MATLAB? Plot x versus t. Do you know what is this FW? It represent what? The drag. Yeah, the drag force coming from the air drag. Yeah. What is the CD? Drag coefficient. What is A? Cross-section area that is facing the air. Yeah. So what I wanted to do is that you pick a vehicle, choose a vehicle. Doesn't have to be the same. Like let's say Philip choose Mazda 6. Erwin. What's your name again? And Adrian, you choose Honda Accord, let's say. Gav, you choose, let's say, Toyota Fortuner. They will have different drag coefficient, yeah. So each of you can choose different car. A car, yeah. We are using a car. Okay. So you pick a car first. which is why you can get the mass of the car, drag coefficient of the car.
Makin bagus makin gitu ya sih drag coefficient.
Yeah, for fuel efficiency, yes. Choose car first, yeah. After that, you build the equation.
Black banget.
Kan ini.
Oh,
Bagus tuh.
bagus dia. Bagusnya bagus biar gue.
Tapi mobilnya bagus.
After you choose the car, then we will do the drag race.
Ini berapa?
Who's faster?
Drag coefficient 0,3.
Hah? Oh, Innova lebih kecil. Innova 0,2 anjir.
Kalah kan.
Ya, itu salah data.
Innova apa?
Innova 0.2.
Bohong lah gila.
That's impossible.
Ini Toyota Innova beneran.
Bugatti aja 0,34 loh.
36.
36.
Innova ini bos. Gila.
Mobil Mister B.
LCG.
Mobil Mister B.
Bilang foto CGC. Toyota di sini.
Ini.
Anjir, ini.
Ini lebih kecil lagi.
Kita pakai ini.
Ini lebih kecil kan? Iya.
Pakai RIV. Beh, RIV-nya S100. Mah 100 kopi.
Oh ini nih. Volkswagen Master Car. Ini 1 liter 10 nih.
What? Mazda 3. Yeah, you can use Mazda 3. Do you have the drag coefficient for that? Wah, so small.
Itu mulai mobil ini. Ini 0,304 loh.
Yeah, define the variable first.
Itu berapa? Ini 0,3 wih. Ini 0,3 wih. Make sense man. Ini juga jadi iya.
A is area, yes. Area of the car. Frontal area of the car. If you cannot get the frontal area of the car, you just multiply the width and the height of the car. Width and height.
Apa yang frontal?
The frontal area, the A, yeah.
Itu A.
Yeah, the A, the frontal area. If you cannot get the frontal area of the car from the web, you just multiply the width and the height of the car. That's easier to get.
Itu C ya? Iya. CD.
Rho is air density. Air density.
Area aja itu.
Boleh lebar apanya? Lebar atas.
Tinggi lah kali lebar.
2.5 tinggi lebar di depan.
Nah, kalau meter ya tingginya. Hah?
Cuma tahu
Apa?
ya dong.
Mungkin enggak lebih berat dari air. Lu mati gak sih? M itu apa? M itu apa? Mas. Berat kan mas kan?
Berat.
Ya. Maju. Kita the weight is big.
What are you writing, Philip?
The Euler method.
Directly?
Oke.
You better write down on paper first. Write it down on paper, and then after that you can write the codes.
Kayaknya nggak usah.
What? Well, you can,
1,
but to minimize error, getting used to
Makanya
writing down on
Makanya
paper.
sekecil apa gila mah kadang kan.
Ya lu sama.
Ngalah sampai ngomong. Berapanya sih?
0,23.
Oh, itu suka sih. Mobil listrik. Iya, berapa?
Oh, berarti 0,8.
Aku mau.
Rumus tulis. Gitu. Hah? Iya makanya aku bisa hilang itu. Aku bisa hilang makanya.
9. Density of-nya lagi.
Density R yang mana?
Oh,
Yang mana? Yang P.
iya, aduh lu bener-bener pro anjir.
Masa apa ya?
Itu
Don't bring that liberal mind gitu.
Milimeter per cm.
Ini 1200.
Oh yeah. This one we have to divide by m, yeah. Correct. Yeah, I haven't divided by m.
Oh itu pakai breakthrough. Oh itu gitu.
Kan gua pakai ini kan. Nomor yang mana?
Tinggal tulis lagi.
So that will be 1 function of k.
Gue juga belum.
Well, yeah, and then you plus it with x2 of k.
Area.
Then
100. Oh no. What is that?
okay, that will be the codes, yeah, in the MATLAB. So remember, this will be constant, yeah, constant, but yeah, you can put k or non k, that's the same. because it is a constant. Anyone start writing the codes already? Yes, you are starting writing the code. Okay, let's plot. Before you plot the graph, what is your expectation on x? How do you expect x to go? Like this, become a constant. Constant means it stops. Any expectation on how the x will look like? Or x1 lah. Okay, make it simple. What about x2? x2 is the velocity of the car. How the velocity of the car will look like? Approaching some value, what, a constant value? Probably means there is a possibility non-constant. Like this? Should be, it can be non-constant.
Must be.
Okay, what is the rationale? It has to be a constant for x2.
Ini
Tapi ini
enggak ini
Ya,
oh
any plot? Not yet.
time juga pakai di doang.
There will be time.
Oh, apa ya? Itu ini yang resolution.
itu kan C.
Oh, CF.
So you define time vector to be 0, dt kn multiplied by dt, and then you plot t comma x2. Let us plot x2 first. x2. See what happened. The C is the friction coefficient, arbitrary. Yeah, you put it a small number, let's say 0.1. Yeah, normally it's very small, 0.001. What? This one? This? Yeah, this is the delta t. So you put dt on the top, let's say 1e minus t. What is dt here? Time increment, yeah. In the Euler method, the dt is the integration time step. Yeah, it is called the integration time step. Yes. That's the x1, yeah. Okay, how do you comment on x1? What happened with x1?
Iya,
In the beginning, it increases. You can make it longer by dragging kn. Make it kn to be, let's say, 1000. Simulation time, yeah. Yeah, so when time is very large, what happened with x1? What happened with x1 when time very large? Became a linear. What about in the beginning? Oh, yeah, it is called exponential. Yeah. So you should find in the early time, x1t will behave exponential. It increases exponentially. When time is very large, it increases linearly. Can you plot x2, Philip? What happened with x2? That is x1. Where is x2? You want to put x, dx. You have the same length. No, t sim times delta t. This is not just the t sim. No, that is t, but this one t sim multiplied by delta t. Dt. The same. You see what's the length of the vector in there? You cannot see it. Yeah. Sorry? CD and C. Which one? That's different. Yeah, CD is the drag coefficient. The C is the rolling resistance coefficient.
Google kok efisien banget. Aku di mana ya, Wik?
No. For I equal to 1 to, not to t, but to some number that is an integer. You cannot put t in there. You put some number which is integer. No need the one. You just put 1000. 1 to 1000. Yeah. The increment will always be 1. Yeah, okay. That's correct. Wait. X2 gimana? Oh, X2 has to be a constant. It will approach a constant. Can you increase the time? Yeah, it's a constant. Yep, that's correct. Anyone get a plot already? Yeah. Philip get the plot already? if you plot x1, it should go like this. Yeah, there is an area where it increases exponentially, and in here it increases linearly. For x2, it will go like this, yeah, approaching a constant. How many choices for the velocity that you have in the end? How many choices for the velocity? Either the velocity increases, either velocity become a constant, either velocity becomes 0. Yeah, the only possible thing is becoming a constant. It cannot become 0. Why? Because we are pushing it, right? We are pushing it. It cannot become 0. It cannot go all the way to infinity because it bends the law of physics. So the only possible thing, it becomes constant.
X2 constant siya.
Huh? X2?
X2.
No.
Oh.
That's, can you simulate for a bigger time? You plot t comma x2.
Astaga.
T comma x2 and then make the kn to be very large. Make it large. Yeah, let's say 1000.
Iklan daripada uang.
Okay. Reduce dt to 1e minus 2. Wah, something is not right. It keep increasing, so make it 10,000.
10,000.
Yeah, you see, so it needs longer time.
Berarti
Yeah, increase it again to 50,000. Okay, so you see.
Oh, berarti it takes longer time.
Takes longer time. So what else? Do you have a plot?
Yeah, I have done like this.
But that's wrong. For what, the x or x dot? For x, yes, that's wrong. Can you plot the x dot? Your differential equation must be wrong if that's the case.
Oh my god.
Yeah.
Intinya harus pakai itu ya, pangkat.
Don't 1e minus 3 without the star. 1e minus 3. Yep, you run it. See, and not right also. You plot it wrongly. I think you plot t comma x, not x comma t. X. That one also. You better hold it. Yeah, this is correct. What about the x dot? After the plot, you write down hold on. No, after the first plot. Yep, you run it again. Where's the graph? Yeah, you have 2, right? You increase the time now. Increase the time. Yep. TF, the TF make it 50,000. 50,000. Okay, you run it.
Oh,
Oh, this one. TF. This is 1 to TF. TF. Okay, now you run. Wait. Yeah, that's too far. I think don't hold on there. Just pause. Replace the hold on with pause. Okay. Yep. You run and then you press back space. Yep. Huh? Oh, the velocity is still increasing. Oh, something is not right. Why the velocity is still increasing?
Velocity the second one kan. X dot kan.
Yeah, the velocity is x2. No, we don't do dot in here. Just there is no matrix in there. Vector. Okay, try you run again.
Iya. Kok salah sih?
Press any key first.
Slotnya apa ya? Kenapa?
Not there. Yeah. You close it.
Kalau portnya berhenti.
Ya, bring it up.
Dari awal udah
Ini gue mau di file yang minggu lalu ini gue mau di file.
Okay, this okay.
Ini file homework.
Yeah, the velocity is not right.
File homework.
It should go into constant.
Tiga gitu kan.
Yeah, you increase again the time. Lowering the dt. dt make it 1e minus 2. Okay. Nah,
Ya salah di sini.
why ft times I?
Oh iya, X
No, not times.
Vroom baru.
No, you don't multiply with I, just ft.
Itu naik dong. Ada
gokunya gimana?
Minus.
Ganti
Yeah, why you have a bracket? Don't need a bracket. There is no need a bracket. No. After ft, how do you define ft?
Si gokunya juga.
What is ft?
Ini apa ya? Lu punya K ya?
So the bracket comes from the left of ft. Left.
Kalau lurus banget.
Yeah, bracket, and then the big one on the right side.
Apa? Itu kan konstan.
Iya, itu kan
Ya. Yeah, now you run.
Kalau misalnya mau ikut nggak apa-apa.
kayak apa aja ya.
Iya.
Something is not right again. I think
Itu
Nah,
this is not plug.
kok beda sih?
Oh, okay. Right side.
my car is still different.
This one no need.
Bracketnya sama.
Yeah, bracket is here. Bracket is here.
Jadi nggak perlu ya, Sar?
That one you need
Here.
left.
Here.
No. On the left of the plus sign.
Karena minus 1/2 V kali itu kali
Before the plus sign. Yep. You need
Bracket.
bracket from here to here.
itu gue sengaja kurangin biar
Here
enak
to
pakai berapa.
here.
Yeah, we have it already, right? Do we have it?
Kayak gue kayak kemarin.
It's alright, Sar.
Yep.
FM nggak?
Yeah, I think we can run it.
FM nggak? 1 sama 0.
Very sure. Oh, you need to press. You put the cursor here. Press that. And now you run it again.
Emang
That's-
konsep apa gimana?
Enggak.
You press any key.
Emang konsep nggak sih harusnya? Oh konsep sih.
Itu cuma 01, Sar. Itu nggak bagus.
Enggak. Apa di apa ini?
Apa?
Something is not right. Wait. Can I get Can you get the cursor here?
Enggak, bukan. Ini
Hmm.
X apa ya? Lu kalau misalnya masuk aku lah.
This one okay. F minus
Oke gitu ya. Oh iya benar.
oh this one you square it.
Ini terlalu ini jauh banget.
Kalau baik
That one you square it. Next dot.
Oh
Oh iya, I press enter again. Oh, man.
Square ya, sorry.
Square after the I.
Ah benar ya, benar ya.
masih aneh.
This one is not.
Ayo kami.
Okay, now you run.
Woi, gue punya gimana ini
Tapi
aja?
kok yang X konstan berarti?
No,
Yang X dot gini yang
that's correct. That is the X.
Oh, udah.
Yang graf ini graf
Isi.
apa? Ini yang graf X apa?
Itu
Ini
yang
X
kanan,
dot
sorry.
This is the first one.
Coba X biasa.
Masih itu sih.
Konstan.
Like mine.
Something is not right.
Tadi plus one, berarti gue ke plus one.
F3 nggak perlu pakai cursor.
No, no need.
Sampai ada.
No need K.
Ini apaan, woi? Oh lu ada ini? Apa?
Ada apa?
Di.
Itu
Iya,
graf tadi. Iya.
Oh.
Ya.
Something is still not right. You have minus one plus. Oh, I have to sit down and see. Anyone get the plot again? What about you?
Nanti.
Kalau X berarti konstan, hampir konstan basically. Kalau X dot agak point.
That's not a constant. That's linearly
Yeah.
increasing.
Yeah. It's
Constant acceleration. Nah.
basically almost kecuali curve di depannya.
Constant velocity.
Ya,
Lihat X2 kamu tuh.
ya X2 nya kayak gitu.
Yeah, that's X2. Correct.
Kalau X
X3.
Hah?
X3 apa? Iya X3.
itu filmnya gitu.
Tapi kalau X apa?
That's a bad joke kan.
Kita subject it.
Enggak.
Screw you.
I'll kill myself.
Okay, we will continue again next week. Now is approaching 11, right? Yeah. We cannot
Like how my
discuss.
graph is approaching a number.
Later after the class, I will see it again.
Jelas gila nih orang.
What I want to do after you get the correct graph for here for this case, okay? What I want to do is that you simulate a real car with the real torque RPM curve. Yeah, that one we will do it next week. Okay. So what we'll do is that we will try to create this curve by using interpolation technique, and then we put it so that we can have the function for the FT. So FT is going to follow the torque curve. Okay. But we cannot do it today, of course. But you have to master the plot of this first. If this is not done correctly, we cannot do the next step. After that, I wanted to simulate on fuel consumption of the car. Okay, and then also you can simulate car drag race, real car drag race. And then I want you also to estimate the required horsepower, required torque, so that a car can finish quarter mile below 10 seconds. We can estimate it using the simulation. So next week we continue. Okay.